Okay, let's see. So this guy is, two sources are in phase. Generate a sound wave with a frequency of 631 Hz. Okay, so let's figure out the wavelength first. Our wavelength is going to be the speed of sound divided by 631. So 343 divided by 631, less than a meter, is 0.54358 meters. That's our wavelength, right? Okay. And now we got to figure out constructive or destructive interference. So let's figure out point P first. Okay. Point P, I'm going to store that in A just for kicks. All right, so at point P, we want to figure out AP, that distance, and BP, the distance from B to P. A to P, B to P, okay? A to P is like, oops. And B to P is going to be a bit longer, we expect, right? Okay, so A to P is, let's do this. We are 8 meters in the x direction, using the distance formula here, right? And then I feel like we are, if we draw across like this distance here is only 0.78. That's 3.78, take away 3. So that number is going to be very close to 8. So let's do this. There it is. Okay. So let's go back and let's go 8 and 0.778. Whoops. All right. This is 8.0379 meters. Now, from B to P is going to be farther, right? So that's going to be in the x direction 8. In the y direction, it's all that 3.78, right? Because of maths. Okay, so let's do this. I think we got it. That is 8.8481 meters, right? So our difference in length is going to be 8.8481 minus 8.0379. I'm going to subtract these two numbers. So that guy minus that guy. That difference in length equals 0.8101 meters, right? Now the next thing, the final thing, is we just got to figure out the number of wavelengths, right? And that's going to be the difference in length divided by the wavelength, right? So that'll be 0.8101 divided by this guy, 0.54358. These are meters. So this is like a pure number, right? Okay, so that guy divided by the wavelength. And I get that that's 1.49 wavelengths, right? So since that's close to 0.5, that is destructive, right? Anything that is something 0.5 is destructive. Ta-da. Okay, so now let's look at point Q. I'm going to erase here. Okay, so again, our wavelength is 343 divided by 631, and that is 0.54358 meters, right? And now we're figuring out point Q. Okay, so AQ is here, and BQ is, well, BQ is 8. Okay, so AQ is the square root of 8 squared plus, and then we're 3 on this side, right? So what is that? Square root of 8 squared plus 3 squared. That is 8.544 meters. Okay. And BQ is easy. That's 8. 8. All right. So our difference in length is just 8.544 minus 8. I don't need my calculator. Is 0. I should look up Brian Tyner. He's the guy that always said calculator. It's a calculator, Mr. Murray. All right. He'd correct my English. All right. So now we got to figure out our number of wavelengths. So that is L over the wavelength, right? So that's going to be 0.544. I think you can see that this is headed toward one wavelength, right? 0.54358. Okay, so that guy minus 8 divided by my wavelength. And that is 1.0008 roughly wavelengths, right? So since that number is closer to a 0, this is constructive. Any number 0.0 or close to 0, that's constructive. It constructs a bigger wave because crest is meaning crest and trough is meaning trough. Okay.